Okay, our last objective, again, is focusing on outliers and its effect on the least squares regression line. We did something similar to this in section 2.4. We were more talking about how it affects the correlation. Now we're talking about how it affects the regression line. So there's an activity here, outliers and least squares regression lines. I ask that you pause this video, go to that outlier or go to that activity and do that first, and then come back to this video and restart it, okay? All right, so note here, least squares regression lines are not resistant to outliers, okay? If you think about with the summary statistics, how it is built, right? So when you do your y equal or y hat equals a plus bx, remember that this b value is defined by using the correlation times sy over sx. And remember that this a value is found by taking y bar minus b times x bar. So it is using the mean and the standard deviation to find the values in this regression line. Well, the mean and standard deviation are also not resistant to outliers. So it should only make sense, right, that outliers are going to affect the slope and y-intercept of a regression line. Okay? So again, all coming first full circle from that chapter 1 discussion on resistance to shape in outliers. Okay, so let's take a look at this example here. It says, example 3, out of the mouths of babes, does the age at which a child begins to talk predict a later score on a test of mental ability? A study of development of young children recorded the age and months at which each of 23 children spoke his or her first word and that child's Gessel adaptive score. The results of an aptitude test taken much later. The scatter plot shows a relation between Gessel's score and age at first word. Along with the least squares regression line, two outliers, child 18 and 19, are identified on the scatter plot. So, again, this is saying that the earlier that you talk, the more intelligent that you are, I suppose. I don't know. They say that female children naturally are more verbal than males. So are they trying to say that females are naturally more have a greater aptitude than males? I don't know if I agree with that. Can you see the sarcasm or hear it? Okay. All right. Anywho, all right. So we see this as a negative association. We would have a negative regression line. Here's most of the data, but you have this child 19 right above the data, and you have this child 18 off to the side. So it says, describe the effect child 18 has on the equation of the least squares regression line. Well, in your activity, I think you talked about points that are horizontally away versus points that are, more vertically away. Child 18 is horizontally away from the data, and it's below the regression line. So we're going to say the following, all right? And again, hopefully this is sort of your outcome from the activity. Because child 18's point is to the right of the data, and below the line, it makes the regression line, and it's actually going to make this more steep. So in that case, it'd be more negative, more negatively sloped. Here, this is what I put in your, I put slope is more negative, right? Slope is more negative. And because it's down here, it actually is increasing and increases the y-intercept. So that says because child 18's point is to the right of the data and below the line, it makes the regression line more steep. That means the slope is more negative and it increases the y-intercept. So this is the line with 18 in it. If you took away 18, this is what would happen. the line would go away from the 18 dot. So notice this. So again, what is the 18 dot doing? It's making my orange line, and again, maybe I'll make it green. So my green line is without 18. So with 18, the red line is it. And what is it doing to the red line? It's making the red line go more steep, and it raised or increased the y-intercept. Okay, so hopefully you can see that. All right, good. Let's talk about child 19 now. So now it says, describe the effect child 19 has on the equation of the least squares regression line. So I see here, child 19 is above the data, right? But it's near the rest of the data. So here's how we're going to say for child 19. So we're going to say because child 19's point is near the other data, and above the line. So because child 19's point is near the other data and above the line, it does not really affect the mean. I'm sorry, the slope does not really affect the slope. What am I talking about? I wasn't thinking. Does not really affect the slope of the regression line, but increases the y-intercept. Hopefully you can see this. Sorry if it's too low. And again, that's because it's going to pull the line up. Pulls the line up. So again, that says because child 19's point is near the other data and above the line, it does not really affect the slope of the regression line, but increases the y-intercept. And again, the idea is this. If child 19 wasn't there, this line would just shift down here. But because child 19 is there, it's going to raise that line up a little bit, thus increasing the y-intercept, but it really doesn't change the slope of the data because it's not to the far left or far right away from the other data. Okay, so be aware of that. These are the two ways that outliers can affect your regression line. And again, notice each time I'm talking about slope and y-intercept. All right, best of luck trying to interpret these and doing the rest of your homework.